Okay, so we're going to go ahead and do the reverse integer. So the first time I actually did this, I did not make a check that it's a 32-bit integer. So some of my integers went to 64-bit integers. Make sure that check is in there. We'll make sure that check is in there. But I missed that the first time. So given assigned 32-bit integer x, return x with its digits reversed. So we'll go in here, reverse the digits. If reversing x causes the value to go outside of the 32-bit integer range, which is -2 to the 31st, or 2 to the 31st minus 1, then return 0. So that's the check we'll have to make at the end. Assume the environment does not allow you to store a 64-bit integer signed or unsigned. So example 1, we'll see 1, 2, 3, it'll return 3, 2, 1. If you see negative 123, it'll return negative 3, 2, 1, so that negative will stay at the front. And then if it's a 0 at the front, we'll pop that off and then return 21. And then the constraints have been mentioned above. No larger integers than that. So I think it would be best, when I did this, it was easiest to do with the integer parsed as a string. It's not super efficient memory wise, but it does the job and allows you to be able to manipulate things a little bit easier than it would be if you just had integers. So what I'll do is I'll say let string num is equal to string x. So we'll cast that as a string, and then we'll just put a string array where we'll split those all apart. So string nim dot split for each piece. So now that integer before is now split into an array that we can manipulate now of strings. So we'll instantiate a reverse array that's equal to a string, and then we'll let an end num equal 0. That will do something a little bit fancy with at the end. So if the string array sub 0, so the first element of that array, good heavens, is a negative. So remember, we split it, so it's a string. So if that first element of the array is a negative, what we'll do is we'll pop it off. So string array dot shift, so we'll take it off, and then we'll reverse the array. So rev array equals, and then JavaScript has this fancy reverse function that we can use. So string array dot reverse, and then what we'll do is we'll put that on the reverse array. Since it's still negative, we'll rev array dot unshift, which will put it back at the beginning, a negative sign. And then what we'll do is we will get the end number, which essentially just means that we're going to parse the string back into an integer. So we'll parse int the rev array that is joined by just empty spaces. So now we've got the array back as a single number or a single string, and then we'll parse that as an integer, so we get back an integer for the end number. If there's not a negative sign at the beginning, so else, what we'll do is essentially the same thing. We'll just combine a few things. So we'll set the reverse array as the string array dot reverse dot join. So we'll just put it back together, and then The end number will just be that reverse array cast as an integer. And then remember, we have to check the 32-bit integer range. So if the end number, so we're checking this on the end number. So now that's an integer, we can do those integer type pieces on there like math.pow. So math.power, so if 2 to the 31st minus 1, or the end num is less than math.pow, pow, negative 2 to the 31st, then what we will do is just return 0. Not return 0, but end number equals 0, because we'll end up returning this end num at the end. And then if that's the case, then we'll return the end num. So everything's handled, everything's nice and clean, and we'll put that forward. So let's see if it goes for us. Looks like it does. 1 to 3, turns 3, 2, 1. Let's submit it, see what happens. Perfect. So as you can see, it's not super efficient. There are more efficient ways to do it, like short-circuiting or dealing with the input as an integer and using some modulus functionality to do that. This just seemed like the easiest way at the beginning to manipulate a string array. The time complexity is going to be right about O of n. It uses some of these different functions will go through each portion of the array in like an O of n fashion. So it's a lot of O of n, O of n, O of n. So it'll just like 4 or 5n, but we'll drop that constant and it'll just end up being O of n at the end. So there's problem number 7.